Hi, today we will going to cover O-level computer science topic number systems. Okay, in number systems, in our syllabus, what we already know is we have binary number system, we have hexadecimal number system, and decimal number system. We're already pretty much familiar with the decimal number system because it's our number system. We're like used to it since our childhood. We just do all the counting in that. Okay, from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right. And when it comes to binary number systems, we know that it only contains two numbers, 0 and 1. And this is used by the computers, machines, robots, and when it comes to hexadecimal number systems, we call it this is the number system of programmers. They prefer mentioning different things, for example, the color codes, for example, let's talk about the MAC addresses because it's pretty lengthy. Let's talk about the assembly language codes, uh, and there can be some other examples as well. So whenever we need to mention a larger number system, we preferred using hexadecimal number system. Okay, let's start with the number system conversions because that's one important aspect part of our syllabus. So I will be using my whiteboard, which you will going to look here or might be on the flip screen at the same time. All right, so let's talk about the binary number system. Binary. Binary, the computer language, and we want to learn how to convert from binary to decimal and from decimal to binary. So we will be learning the binary to decimal conversion at the same time from decimal to binary as well. Okay, so let's talk about the binary decimal conversion. In binary, we can take an example. If this is a number, even by looking at it, we can see that it's a binary number system. Further, they can also mention it with the base. This base means that this number belongs to a binary number system. It could be 1010 in the decimal, but it's not. It's a binary number system because the base is also given. Right. So how to convert it? We're going to simply use this method, this rule, that the binary number system, every next bit power gets doubled. For example, just let me rewrite this question here. And this is the series, this is the pattern that you need to remember from binary to decimal, from decimal to binary conversions. The combination will start from right towards left. 1, to start with 1, and you double it every time. 2, 4, 8. If there would be a fifth digit of binary, the power of that digit must be 16, and then 32 and 64 and 128 and 256 and 512 and 1024 and 2048 and 4096 and 8192. In our syllabus, we have to, in O levels, we need to remember this pattern up to 2048, okay, because they can give us up to 12 bits long binary number or a hexadecimal number. Okay, so once we have this 1248, we can convert it like this. Wherever the numbers which have one beneath them, or you can say it, if we multiply every power written up there with the number, so 1 multiplied by 0, it will become 0. 2 multiplied by 1, it will become 2. 4 multiplied by 0, it will become 0. And 8 multiplied by 1, it will become 8. So the answer will be 10. This does look like binary, but it's not. It's the 10 of decimal number system. So the base is there. So if you want to tell 10 to computer or a machine, you need to tell it 1010. All right, so this is the conversion. You can also take an example of the larger numbers. Let's have a look. Just let me clear the canvas. Okay, if we have a bigger number like this, take such example. Now, I've just taken this example intentionally because we will going to learn one another thing inside of it. So we have 1111. It's an 8-bit binary number, and all the bits are 1. And to solve this question, just rewrite it. Start putting the powers like this. We know the pattern. There we go. Now, instead of doing this laborious thing of adding all the numbers 128 plus 64 plus 32, 16, and we know that in Cambridge and O levels, and A levels as well in computer science, calculators are not allowed. So we have to find the smarter ways of solving these questions. So how are we going to do that? Let's try to find a way. Yes, you can do that. You can solve this question by adding all the numbers, but there is one another thing which we will going to practice right now. For example, if you have, for example, I'm just skipping this question for a while, and I'm just giving you one another example. For example, you have a number like this. It's a smaller number. It has 4 bits. All bits are on. They're 1. And if you start putting power like this, 1, 2, 4, 8. And if you add all of them like this, it will become what? 15. Okay, now listen carefully. If in this 4-bit digit, if I ask you what will be the next power, if there would be a fifth digit, after 8, it would be 16, right? So you just subtract 1 from the next bit power. So it will be like 16 minus 1, it's 15. Or you have a formula, 2 raised to power n minus 1, which you can call it. For example, you had 4 bits, all of the bits were 1, okay? If all the number of bits are 1, so what it will going to make? 2, 4 minus 1, it will make 15. Or rather complicating it, just remember this part. Just remember this part. Subtract the next bit power with minus 1. So if you take another example, let's take another example. 1, 2, 3, 4, 5. And you switch on all the bits, rather adding them all up, which you can do. All right. There is a smarter way. The smarter way is what would be the next bit power after 16? It would be 32. So 32 minus 1, if all the bits are 1. So this will be the answer. If you add them like this, it will going to make 31. 31. Smarter way. Okay. So if you have a question like this, in which all the bits are 1, so you can simply tell that this goes up to 128. You know what is the next bit power? 256. So 256 minus 1, 255. So if you have 8 bits and all the bits are 1, the maximum decimal number that you will going to get is 255. Now how this thing will going to really help me out? Let's take another example. For example, a larger number like this one is given. It's an 8-bit number. You start putting the powers to convert this number into its binary equivalent. Instead of adding all them up, 128, 64, 32, 16, 8, 4, 2, and 1, what you can do, you know that if you switch on all the bits, if you add all them up, it will going to make 255. What is the piece that is missing? It's only 2. So 255 minus 2, answer must be 253. Just for the sake of practice, just go through this, add all the values up, 128 plus 64, 32, 16, 8, 4, skipping 2 and 1, it will going to produce 253. So what if they're going to give you a larger number like it should be 12-bit, and only the second or the third bit is off. So instead of adding all the numbers up, what you can do, you can just minus those numbers from the actual bigger value. So this is how you can solve the binary decimal thing. Once you have learned this binary to decimal conversion, which we were doing, converting binary numbers to decimal, you just learn the decimal to binary conversion as well. How's that? It's pretty simple. For example, you have this number 253 and you don't know the binary number. That's it. You don't know it. And they ask us to convert this 253. Right? This is a decimal number and they're asking us for its binary equivalent. You just made the pattern again, the same pattern. 1, 2, 4, 8, 16, 32, 64, 128. You can go above that to 56, 512, 1024, so on. But the value that you are converting is to 53. So there's no reason of, because ultimately you're going to put 0 underneath them. So 128, you just switch on those bits. Adding those bits up will going to make up your number. But we have already done that drill that if we will going to switch on all the bits, it will going to make 255. So we just need to skip the 0, you 253. So this is how you can convert the decimal number into binary. Just for the sake of making it a little bit more simple, let us try a simpler, easier question. So if somebody is having some sort of a difficulty, they can have an idea. For example, if we have a number like this one, let's call it 57. It's a decimal number. We need to convert it into its binary equivalent. Just start making the pattern. 1, 2, 4, 8, 16, 32, 64 is not required because ultimately 0 will go underneath it. So how to make 57, 32? Let's switch on 32. Now we have 32. Add 16 into 32. 32 and 16 are on. Now we have 48. Okay, 48 and let's try to switch on 8. 48 and 8, it will become 56. Okay, we're just almost near. 56, we cannot switch on 4 because it will going to make 60. We cannot switch on 2 because it will going to make 58. Switch on 1. There you go. So this is your binary equivalent. So this is your binary to decimal conversion. So these are the conversions that we have done so far: binary to decimal and decimal to binary. We had a little bit intro. In next class, we will going to talk about binary to hexa and hexa to binary conversions. I will also going to give you some notes. We have a website with my name. You can download all the notes, all the booklets, all the working past paper worksheets absolutely free. We have groups. If you are my regular student, if you are my student from the college or an institute, you can already know my number. You can just approach me. You might be probably in our group through which you can put your queries. But if you're watching the video, and welcome aboard, just let us know. Feel free to contact. Happy learning and stay safe in this epidemic period. All the best.